Hello, hello. This is Postgres FM, your favorite podcast about Postgres. And my name is Nikolai. My co-host is Michael.
Hello, Nikolai.
Hi, Michael. And we have a very good guest today, Sai.
Hey, Nick and Michael.
Founder of PeerDB. We are very glad to have you here. And we just discussed that we are not inviting guests just for guests. We choose topic first, so it's topic-centric discussion. But my first thought when we discussed we need to talk about logical, and also I saw your blog post published recently. My first thought was you're a very great person to have for this discussion, right? So that's why we invited you. Glad you found time to join.
Thanks, Nick and Michael, for inviting me. And yeah, logical replication and logical decoding has been my life since the past 7-8 months, and we are trying to get into as much depth as possible to understand how it works and probably down the line contribute upstream as well. But yeah, I'm very excited to be here.
Cool. I know Michael has a lot of questions, so I probably will be less active this episode, but I will have questions as well and maybe comments.
Yeah, I definitely have questions. But yeah, I completely echo everything Nikolai said. And yeah, we did a kind of a basics intro episode to Logical where Nikolai also talked us through how to handle scale in terms of major upgrades, at least. So that's a common use case for Logical. But one thing we didn't even touch on, which was the topic of one of your recent blog posts, was I listened back and I think protocol versions got a single mention, kind of like an off-the-cuff mention at one point in the episode, 30, 40-minute episode. So that was where I was thinking of starting. Is it would be awesome to hear a little bit about the protocol versions, why you wrote about them recently.
Yeah, absolutely. Thanks, Michael. So the thing is, logical replication has this concept of protocol versions that you could specify as a part of the subscription, or if you are like an external client who is reading the replication slot, you could do it as a part of the start replication API, which lets you read the replication slot. And there are 4 versions that Postgres supports now with Postgres 16, right? The first version is the default version, which decodes transactions that are only committed. So it doesn't start the decoding process before the transaction commits. And the second is the more advanced option, which does logical decoding of transactions that are not yet committed, right? So it basically does decoding for in-flight transactions, right? That is number 2. And then third is it lets you decode two-phase commit transactions. That is third. And the fourth is it lets you decode in-flight transactions and apply them in parallel to the target, which is the subscriber, which is Postgres basically, right? Now, in that blog, which you're talking about, we compared version 1 and version 2 because they are more like the common ones. Two-phase commits are not very common, right? That's the reason we didn't go into that piece. But the biggest difference is the impact of 2 is it improves logical decoding performance because you're actually decoding while the transaction is happening, right? You are not letting the transaction finish and then only start decoding, but rather you're decoding as the transactions go on. So the idea is you're giving more time to the decoder, the wall sender process, to perform the decoding. And now this has a lot of benefits, right? Number 1, it reduces the slot growth, right? So in that blog, we talk about a situation where we have 2 long running transactions that are being committed. And with version 1, the decoding process doesn't start and the slot keeps growing. And only after the transactions are committed, the decoding starts. And then for a few minutes until the decoding is finished, the slot size remains the same, right? Now, this is with 1. With 2, what happens is as the transactions happen, decoding starts, right? So you do see the decoder doing its job. And as and when the transactions finish, the slot immediately falls. And the advantage of this is, so the summary was with version 1, the slot growth of I think we showed 5-6 gigabytes remained for 5-6 minutes until the entire decoding finished. But with version 2, it remained there for an instance because, the decoding was already happening as the transaction was going on, right? So this can have tremendous impact in use cases which have long running or sizable transactions. And that is very common, right? Like we recently were working with like a fintech customer, right? Like where they had like sizable transactions, right? Like hundreds of like, operations happening in a transaction. And then these transactions were like interleaved. And now the advantage with like the two would have helped them a lot, because as the, operations are happening, the decoder like, just decodes them. With one, the problem that was happening was there was one long running transaction which took like an hour, and then every time the decoder needs to decode committed transactions, it was decoding this long running transaction also. So the order of time is more quadratic basically with like version 1, right? Because WAL is like sequential, right? Like, so you keep writing, and then as and when there is a commit, like the decoder like starts like working. Now the problem is with version 1, as the existing like the long running transaction is not getting decoded, still the decoder process decodes it for like other transactions, right? So but with like 2, this problem wouldn't have happened, because once this long running transaction is committed, I mean, it's already consumed, it's already decoded, if that makes sense, right? So the high level summary is version 2 is very helpful when there are like, long running transactions that are like, interleaved.
So the lesson is upgrade, guys, right? Just use the latest Postgres version.
Version 2 comes with 14. Version 4 is in 16.
Sorry, I've not small thing. I've noticed you mentioned subscriber, which is Postgres. This phrase attracted my attention. It's not always Postgres, but parallelization, which to apply long transactions, it's done only for Postgres subscribers, not for others, right?
Correct, exactly. So the 4th version, which does like parallel apply of these in-flight transactions, is more relevant for Postgres to Postgres replication, right? The apply piece is Postgres, and that's the standard logical replication. And logical decoding is more like a subset of logical replication, where external clients like PeerDB can read the slot and replicate to homogeneous or heterogeneous targets.
Super. Yeah. In your experience, does it mean that there is no sense to have this feature for other situations like to Snowflake or others?
The parallel apply feature, you mean, right?
Yeah, right.
Yeah. Good question. So that is the onus of the ETL tool, right? Like, so in PeerDB, we have a option to do parallel apply or not do parallel apply. So it's like a single flag that we provide. And the difference is with parallel apply, we cannot guarantee the order of transactions across tables, right?
So foreign key and referential consistency, similar to multiple slots in regular Postgres to Postgres logical.
Correct. Very, very similar, right? And then both, I mean, customers do it. The advantage of parallelism is it will improve latency, right? Like replication latency reduces, lag reduces, etc. But it doesn't guarantee, consistency across tables. But the sequential does that, right? So customers, like we have both customers.
Yeah, that's interesting. I know, like in many cases, people think, okay, we work at like half of our capacity, no worries if TPS grow. Using a single slot. If TPS grow, we know the bottleneck is on subscriber, we will just use multiple slots. But then they realize that foreign keys, you need basically to agree that they are broken temporarily on the subscriber and can cause a lot of troubles if you point application to such nodes, right? It's interesting. Yeah.
Absolutely.
Makes sense.
And I did want to call out, right? Like for that, I mean, there is a setting for disabling foreign keys. Just to like, complete that, there is a setting called session replication program.
Right. But
basically, you can set that as replica, and that is pretty standard, right? Like that's the reason Postgres gave this setting. So you can set that to replica, and it would disable foreign keys and triggers on the target.
But it ends by default. If you use multiple slots, it's disabled.
By default, is it like disabled?
Yes. I know it since recent works to use it for upgrade with zero downtime upgrades. So it's indeed disabled, and it's interesting. Like, so you need to like think maybe you shouldn't use it. I mean, maybe go back to single slot and just choose different time for your work. I mean, work on weekends, guys, right?
Yeah.
Lower traffic, and you can afford working with single slot. This means only for like logical for temporary time, like for upgrades. We don't need it
Exactly.
for
It
long
really
time,
depends
right?
on the use case.
Yeah. But if for long time, forget about foreign keys maybe.
Yeah.
And you said latency, but it's also about throughput. We need to process more bytes per time, and yeah,
Absolutely.
and legs can be nasty. I don't like dealing with logical in Postgres 11, 12. It's like not pleasant at all. It's
Yep.
So these improvements are exciting, and everyone should upgrade. That's what I see here. You uncovered a lot of details. That's great.
Yeah, absolutely. And the tricky thing, I mean, the beauty of like Postgres is that like this is already inbuilt in like Postgres core, right? Like, and logical replication does this by default. It's just like, a setting you need to do, say that like, hey, I want to use version 2, and it will be significantly more performant, reduce slot growth. But if it's an ETL tool who's using logical decoding, the transaction logic needs to be managed by the ETL tool, because as you're reading like in-flight transactions, we need to keep track whether this transaction is committed or not, and then only push it to the target. So it becomes tricky for like ETL tools, which we are working on in PeerDB now as we speak. But the beauty of Postgres is that it just gives you this setting out of the box, and you just need to upgrade your Postgres version to 14 or 15 and 16. So yeah.
And with this in 16 we have example. I mean, the developers of these tools, like your company, they now have example Postgres to Postgres native logical shows how it can be implemented. So the reference example exists. So it's good. Yeah, that's great. Sorry, Michael, I interrupted you.
No, not at all. This is a really good diversion, but we've talked about three things already, right? We've talked about throughput, we've talked about lag, and we've talked about slot size growth. And I feel like when you said initially the performance of the version 2 protocol can be better, I'm guessing we're talking mostly in terms of that lag metric. Like we can start processing things faster, therefore the lag is lower, makes total sense. And when you said the slot size growth is reduced, I think I understand where you're coming from. I think the specific benchmark in the blog post shows that the growth is the same, but then it kind of reduces quicker. But when you mentioned the like interleaved long running transactions, I guess it's in a less synthetic workload where you've got lots of potentially overlapping long running transactions. The peak will be lower in the version if you're using. Great.
Exactly, right? Like, because in the scenario we did, it's like just do 2 transactions that are long running, and then we just had 2 of them, right? But then they ended at the same time. But in real world workloads, like it can be very arbitrary, right? But with like version 2, as the slot consumption is faster and like slot size falls quicker, right? The cumulative effect can be very significant in slot growth.
Nice.
If that makes sense. And that is the next benchmark we want to do, where in the real world benchmark, I want to see how does the peak slot size like compare with version 1 and version 2. We are actually building that feature. So we plan to like, we have a few like customers we are design partnering with, to implement this feature. And we have like, we know, what is the peak size, slot size we are seeing with version 1. And with this design partnership, we will get to know, okay, what is the peak slot size? My like understanding is it will fall very quickly, because like, you're giving more time to the decoder, right? Like it's more efficient. And with these long running transactions, it cannot be quadratic, like the decoding process, right? So, but that's a very good question you pointed, Mike. And that is the next like, benchmark we want to do. So
nice. So then the question then becomes, are there any workloads? And I'm thinking now that it must only be if you had, let's say you had a lot of long run transactions that end up getting aborted or rolled back instead of committed. I'm thinking that might be the only case where the version 1 protocol might be you might prefer to carry on using it, or are there other cases where you might prefer to carry on using the V1 protocol over the V2 one, as long as you're on 14 above? Even
when the transactions are rolled back, the wall is not removed, so it still need to be like decoded, basically, right? Like for future transactions. That's exactly what happened in a customer scenario where there was a long running transaction which the customer killed. Basically, it was running for like few hours, right? But still that impacted other transactions, because Postgres is not yet smart where it removes the wall.
This is my favorite use case. So you can overload wall sender if you just do very simple trick. You create a table with like 10 million rows and then delete rows in transaction and roll it back. Massive delete rollback. I like this workload in many cases, and this included. And this makes wall sender consume 100% CPU very quickly because it needs to. Yeah, because this transaction spams wall, writing Xmax constantly for a lot of tuples, and then saying, okay, this Xmax, this CT, this transaction ID was rolled back, so it doesn't mean like they're still alive, right? The next transaction comes, does the same, and wall sender is becoming crazy. And I think there should be some way to optimize decoding to understand it. Maybe because if you start processing, when it starts processing, it's not known that this transaction is already rolled back. But maybe there is like some opportunity to optimize, because if it's known already, it's already rolled back. Why we can probably skip better or something. I don't know. I don't know details here.
That's a very good point, Nick. And I was recently chatting with one of the committers, and we don't even like skip rows is my understanding, basically. Like, so every time like we try to decode, basically. So the immediate optimization is if there is a entry in the wall of like a rollback transaction, then we don't decode that entry in the wall, right? Like, but you bring up a great point here. So there is a lot of scope of improvement there. So
yeah, and this led us to the conclusion that we won't be able to deal with logical at like a few modifying transactions per second. It was wrong conclusion because this was like it's pathological workload, and in production, I think it's very rare case when wall sender is hitting 100% of single core. Or it's not. I'm not sure, because the problem is you cannot scale it. You add second slot, but you see wall sender is hitting 100% of single core CPU with the constantly or from time to time, and you think, okay, I will try to distribute workload among 2 slots or 4 slots, 8 slots, but this doesn't help. All of them are hitting 100% of different cores, and that's it. So this can be bottleneck, but it looks like it's very rare right now in production.
Yeah, absolutely. And that is another optimization that like, the community could do is where we, currently if there are multiple slots, right, like the decoding process runs for every slot, right? Yeah. If there are ways in which the decoder runs for just one slot and the other slots reuse these like decoded changes, right? Like if that makes sense.
Yeah, exactly. The same work that's done multiple times.
Exactly.
Everyone is process everything. This is what, definitely there is opportunity for improvement here. But I think people just don't see this as bottleneck in production often. That's why it's not optimized yet.
In production, what we see is like it's like these one-off batch operations where customers delete like a bunch of data or add like do copy with like millions of rows where there is like a wall spike. And the recommendation that we give, right, like is guys have more disk. It's hard because like
faster disk.
Faster and like larger disk, because logical replications can only scale up to 25,000 to 30,000 messages per second basically. So have larger disk so that like once this wall spike like falls, it'll catch up. Okay, sure, at that time there is more latency, right? But
it's a good CPU if like 25,000-30,000 messages per second, because for PG Bouncer on modern Intels and AMD, I didn't see more than 20 messages per second. We can compare this, like also messages per second. PG Bouncer processes transactions just by passing them to backends, Postgres backends, and returning result. And logical replication also similar, some messages, right? Different type of work, because decoding maybe is more consuming, but 30,000 sounds very good number.
Yeah, 100%. But the thing is, it has to be done well, bro. No, it has to be done properly, because like one of the tip that we do, right, like which I've seen lack in a few ETL tools is always consuming the slot. We cannot give up on consuming the slot. We need to constantly consume the slot and flush the slot, right? And
not to lag, right?
Not to lag. And the thing is, if you give up and start reading it again, it doesn't read from the confirm flusher lesson. It reads from the restarter lesson. Right. And sometimes that restarter lesson can be very like old. And I don't want to get into when Postgres like updates the restarter lesson because it's a more complicated thing. But the idea is when I give up the connection and read the connection again, it starts from like restarter lesson, right? Which can increase my decoding times a lot. So this is very common when we initially built PaDB, like if the slot size was like 150, 200 gigs, right? We were giving up connection periodically. And like whenever like this slot is big, for like 10, 15 minutes, it was just stuck in Volread.io. It was not even getting one change. So that is one tip I recommend, like, where you always consume like the replication slot.
Right. I was trying to recall another problem I saw when inspected what's happening if you start using multiple slots. And it's kind of interesting problem. When you start publishing changes to a single slot, you use for all tables, for example. Right? If for example, for upgrade, it makes sense. And this is great. It works very well. But if you start distributing tables among multiple slots, you need to alter table, I think. Anyway, like you need a lock for each table individually in the group. So you divide in groups, and then you need to alter start publishing changes. And this is similar lock as like DDL, basically. No, not similar. It's not exclusive lock, but it's shared. I remember it got stuck. It's not exclusive lock. Yeah. So it's not that bad as alter table as in column. So I remember it got stuck. It couldn't complete, but at least it didn't block others.
Right. And was this while creating the multiple slots, or was this like just like creating publications?
Publication, yeah. So you do specify tables for which you need to create publication, and this needs to acquire locks on all of them. It can be successful for some of them, not successful for others. It's a single operation, so you're waiting, and this is not good. But not that bad as DDL, which can block selects which come after. We discussed many times how dangerous it can be under heavy load. Yeah, that's interesting. Anyway, multiple slots are tricky. This is the lesson here. So you need to test and learn before using them.
Yeah, so, absolutely. Yeah.
Good. What's next?
Well, before we move on from that, I'm interested in, are there any other like hard limits? So you mentioned that rule of thumb, kind of 25 to 30,000 messages per second. Like, are there any other like rules of thumb or hard limits or anything that people could be thinking, oh, we've probably not tuned it enough because we're not getting that much throughput or that low lag or something like that?
I guess this number depends on the core, on the type of CPU you have. If it's old, it can be 10,000, for example, or something.
Yeah, 100%. And this setting is, this number that I shared is more in like, on the higher end in a non-local environment where like, the source, the target are not local. They are like in the same region, like, but in different boxes. So network latency is a very big factor. One thing we do want to see is like what is the logical replication performance when both are on the same local server, right? Like, which is not in real world, that doesn't happen. So this, whatever I'm saying is like, network latency bound because it's single threaded, right? And the network latency kicks in and it can only scale up to say 20, 30 Mbps if it's like, 30, 40 Mbps, if it's done well also, right? So those are also some things to keep in mind. Now, coming to gotchas, right? Like a few things that I did like, make a note of logical replication. First is it doesn't support like replication of DDL commands, which includes like adding of columns, like dropping of columns, like, adding new tables, creating indexes, like, truncating tables, right? Like, so these are not supported out of the box. And this is one of the common concerns that we hear from customers, because in the real world, people, you add tables, you have these Django migrations, which like add a bunch of indexes, etc., right?
Partitions we talked about last time.
Yeah. They don't do that also. So
yeah. When you say customers raise it as a concern, is that before starting or like realizing it later on? Where does that pop up for you?
It happens both ways, right? Like, because obviously Postgres logical replication is the easiest way to like, replicate databases, right? They start off and then there's a column that is added and then logical replication breaks. And now the good thing is you can add a column manually on the target and it would continue. But then this becomes like difficult in production, which is when they reach out saying that, hey, you guys like are also, doing using logical decoding and you support Postgres as a target. And that's how like they come to us. And we do support like schema changes, but like only add columns and drop columns. We don't yet support like, creating tables and like, indexes and like, truncate and all of that yet, basically. And sometimes it's like it happens before itself, where like, okay, this is we keep adding tables, we keep like adding columns very often, and like this doesn't work for us. So like we want another solution.
Yeah, nice. A couple of the other things that I see people confused or struggling with are things like sequence synchronization. I guess that's just a one-off task at the beginning. Do you see anything else catching people out?
That's a good question, right? Like I think DDL commands is number one. Replication slot growth issues is number two, which we talked a lot about, basically, right? Like, and always keep reading the slot, avoid long running or like open transactions, monitor slot growth, right? Like fourth is, use protocol versions, right? Like upgrade to like latest Postgres versions and start using the version 2, 3, 4, which is faster, right? The third thing that we see is Postgres logical replication doesn't replicate, toast columns out of the box. So you need to set up replica identity full to, make that happen. And replica identity full could be expensive if you're not on Postgres 16, because for updates and deletes, it could lead to like a sequential scan.
And in 16, what happened? CTID was used or is used, or like why it's better in 16?
It's using indexes now. It's like using indexes basically.
Okay.
And the thing is,
if you have them.
Yeah, if you have them, and if you have the right indexes. And another thing is some customers, right, like who have primary keys but they have toast columns, we still like need to do replica identity full, and that helps. So replica identity full with primary keys is more efficient. And there is a good blog that the Zata guys wrote, like, which I really liked. And that is something that I refer to customers where, hey guys, like you can add this. I think it increased like CPU and IO by 30%. That was their analysis. But that is about like toast columns where you need to have replica identity full, and the impact of that can change based on scenarios.
Yeah, awesome. I didn't know about that one. I would love to read that blog post. If you send it to me afterwards, I'll include it in the show notes as well.
Absolutely. And the fourth thing that we have seen is logical replication, at least, logical decoding did not support virtual and generated columns. If there are like generated columns, they didn't show up on while decoding. And the way we easily solve that, is on the target, the customer set up like a virtual column, or they use like DBT or like some transformation tool to, backfill this, right? Like, so that is number 4. And then last but not the least, the fifth one that we see, right, like I'm still, trying to discover that is like slot invalidation issues where the restart LSN becomes null. And I have seen that happen in 2 scenarios. So the first scenario is there is a setting called max keep slot size or something, which actually limits the size of the slot. And this setting was recently added, 13 or 14, which lets you like safeguard from storage, out of storage issues. So as and when the slot hits, over 2 terabyte, right? Like, or if that's the setting that you have, it basically invalidates the slot. And in that scenario, the restart LSN becomes null and the slot gets invalidated and you need to restart logical replication. The second scenarios we have seen is sometimes it happens randomly also and we are still figuring out why that can happen. And now we reached out to the community, right? Like, and we heard that like it could be because of cloud providers Postgres, right? Like because cloud providers have a bunch of like backup operations, some folks, slightly fork Postgres, right? And then it could be, the community doesn't say that, like, their point is like, can we try to reproduce this on vanilla Postgres, right? Like not cloud. And then that was not becoming easy for us. But like we have seen that out of the 7 to 8 months, 1 to 2 times, randomly the slot gets invalidated. And we don't have like an RCA on when that can happen. And immediately we think that we check, hey, is the max wall like keep slot size is like less than, is it set up, right? But it's still -1, it's disabled, but still like we run into these issues. So I'm on that quest of figuring out when this happens, because right? But that is another scenario.
That's terrifying. And yeah, how do you even begin to go about reproducing that? Good luck.
Exactly. So we were able to reproduce this on one of the cloud providers, where like for high throughputs, like over 50K transactions per second, every 15 to 16 hours, it was like getting invalidated. Right?
50,000 per second and every 15 to 16 hours.
It's a lot, right? So
that's a lot of messages.
That's not real. I mean, I don't think that happens often, but yeah.
No, wow. Cool. I don't feel like we talked about use cases much. Is that because these aren't use case dependent? I guess other than people using two-phase commit, do you see any differences between people that are using logical replication for analytics databases versus for... did you see any difference between use cases, basically?
Good question. Like, I mean, logical replication is very powerful. I mean, it supports like, migration, online migrations, number one. Mm-hmm. Then it supports like online upgrades, right? Like which Nick mentioned, right? Like number two. Number three, it also supports like HA and backup scenarios, right? So I have seen some customers who use logical decoding or logical replication to have HA across regions or in like hybrid environments, right? Okay, I'm running stuff on cloud and I still want to have a backup or like a replica on my on-premise, like, self-hosted environments, right? Like, and the only way it's possible is via logical replication, because cloud providers don't give access to like WAL, right? That is number three, where like HA and backups is another use case, right? 4 is replication to like non-Postgres like targets, or even Postgres targets for like workload isolation, use case isolation, where, okay, I have my OLTP database running on Postgres. Now I want to put this to another database, like it could be Snowflake or Postgres for analytics, or for search. Like I want to put this on like ClickHouse or like Elasticsearch, right? Like for optimizing search. Yeah, logical replication is very powerful, and I believe that it's going to be the future of Postgres. And down the line, it can open up like active use cases also, right? Like where, okay, you have like cross region. And I recently read a blog where folks were using logical replication for like active, right? Like, so, I mean, it opens up like a plethora of use cases and makes Postgres more, powerful, extensible. And yeah.
Yeah, I read that blog post too. I think it was version 16 change that made it possible to like not replicate changes that got made by logical replication. So you could kind of like set up logical replication in both directions. But it seems super dangerous to me. Like, okay, cool. Would you recommend it at the moment, or do you think we need more features before that? So
I think it's more, I mean, it's more like intense than that, right? Because like conflict resolution and all of this is tricky, right? Like, and I mean, if it's like very workload specific, where like, okay, I don't touch the same rows, right? Like, and maybe there it could work, but I mean, out of the box, like implementing that is tricky, and it requires more like effort. And maybe we go there in the future, right? Like, because we are seeing a few like cases with customers where they want active, and there is not like a out of the box solution. So
why do people need active?
Good question. I think I have like a lot of thoughts here. So like the thing is, I think it really helps with like HA, right? Like for example, I remember this scenario in Microsoft where customers were having like a bunch of like SQL Server active across regions, and then this was a bank, and then one of the region went down, right? Like, and then every second is like thousands of dollars, and then they immediately pivoted to the other region, and it kind of worked seamlessly, right? Like, so
but doesn't it mean that all clusters need to perform the same rights? And I was like, I didn't buy this idea that replaying logical changes through logical replication is less expensive than applying them initially, which was advertised in the BDR documentation. I didn't buy this. I hope to find time to test it properly in blog post, but I so far didn't find time yet for this. It's an interesting topic, because like in BDR, it means like, for example, you have multiple regions, 4 or 8. I know such cases as well. And they suffer because everyone needs to perform the same rights, and if there is spike in one region, or this, like, it's not resilient system at all.
Yeah.
I don't understand this.
Yeah, 100% agree. I think, I mean, that's the reason there is a big opportunity there. And I recently saw one company, right, like the PG Edge, who are like trying to do something like this.
Yeah, new wave of this.
Yeah,
I know every CTO is dreaming about this. I know it. Because we work in multiple regions. Yeah. Maybe we should first check that all our physical standbys are in different availability zones than primaries, right?
No, I 100% agree. There are more basic things, Nick. I agree.
Yeah, but multiple regions is a great thing to have, but still, like, I'm very skeptical. But I see there is, in DBA's mind, there is mind shift as well. Like 10 years ago, all DBAs said you don't need this, but things are changing. So in
100%.
Postgres 16, this to avoid loops, infinite loops, right? This feature, it's interesting. So, but I still I don't understand use cases and how like we can scale writes if we don't split them, like in sharding. We split them in sharding, and that's great. Here we like everyone needs everything. Well, I'm very skeptical still. I don't understand this part of landscape.
Yeah, 100%. And like, I think it becomes very critical in tier 0 use cases, guys, right? Like, I mean, not like, I mean, tier 1, tier 2, tier 3, I think it's kind of lesser, but like, it's more these tier 0 where like, it's like a Chase Bank or something like that, right? Like, where it becomes like hyper.
But you think it's possible to build a good system?
No, I don't think it's, I mean, with Postgres, I'm also very skeptical, but I think there is an opportunity there, right? Like, and community, both community and like, I mean, community will be very critical here. Right? Like I don't think that it can happen just by logical replication.
Maybe if we build system categorizing data in tiers as well and replicating writes only for most critical data between regions, right?
We're probably tiptoeing into a different topic here, but it has been interesting.
It's not different. It's not different. Many people think logical leads to multi-master, definitely, like so-called old term. So,
but I think the tier 0 use case like feels like it's a long way from being supported by native Postgres. Like there are a lot of providers out there for that kind of thing, and I think the general term for it is being called distributed SQL or like that seems like dist SQL is what I've been shortened to.
DSQL, basically.
But I would warn people against using logical for this in the short, like anytime soon. Yeah.
Okay.
I agree. 100%.
Well, okay. Then what other questions do you have?
I didn't have anything else. I wanted to thank Sai. Did you have anything else, Nikolai?
Well, no. Thank you so much. It was interesting. Thank you for coming.
Absolutely, guys. I really enjoyed like chatting with you, and thanks for like inviting me. And yeah.
I hope you won't stop posting interesting technical posts.
No. So content is our currency, guys. I mean, like, and the thing is, for me, like, I'm building the company because I'm very curious, right? Like now the thing that is like haunting me is that slot invalidation, not like, I'm not understanding why it can happen, right? Like, so because of curiosity, we will be publishing a lot of content, but
benchmarks, graphs, data, and so on, reproducible. Absolutely. Also. Yeah, that's great. Thank you so much.
And also, if any of our listeners have seen that as well, or have any theories, or have a reproduction case for it, let us know.
Absolutely.
Good.
Wonderful.
Thank you.
Thank you both. Take care.
Thanks, guys. Bye-bye.
Bye.
Bye-bye.
Bye.